How fast would an object need to be moving to completely shatter Mars's surface and create a crater 15 kilometers wide? The answer is exactly the speed that 3IATLAS is traveling right now, 87 kilometers per second, with a 12 billion-ton mass that includes a mysterious metallic core. NASA's latest classified data reveals this isn't behaving like any natural object we've ever studied, and the trajectory calculations are becoming more terrifying with each update. In the next few minutes, I'm going to show you the evidence that has Harvard astrophysicists questioning whether we're looking at alien technology, why the object's clockwork pulsing patterns are impossible to explain naturally, and exactly what will happen if this thing hits Mars in September. On July the 1st, astronomers made a discovery that would soon ignite heated debates across the global scientific community. A strange object, later designated 3IATLAS, was spotted entering our solar system. At first glance, it seemed like a typical interstellar comet, the kind of icy body we might expect to pass through from the far reaches of space. Astronomers assumed it would behave like countless other comets, approaching the sun, venting gas and dust, and then fading back into the blackness of interstellar space. But as more data began to pour in, it became clear that this was no ordinary comet. The orbital path, the speed, and the very behavior of 3IATLAS stood out as anomalies. Most comets are unpredictable, but still bound by the chaotic physics of ice and rock. This one seemed to be operating with precision. That's when Harvard astrophysicist Avi Loeb, already known for his bold suggestion that another interstellar visitor, Oumuamua, might have been artificial, stepped forward with a theory that shook the scientific establishment. Loeb suggested that 3IATLAS might not be a random chunk of rock and ice at all. Instead, he proposed it could be some form of alien technology, a piece of machinery traveling between star systems with a purpose we do not yet understand. At first, many dismissed his claims as speculation. After all, it is easier to assume natural origins than to leap to extraterrestrial explanations. But as telescopes tracked the object night after night, the data started leaning closer toward Loeb's controversial idea. Its movement did not entirely match the behavior of a passive natural comet. Instead, it appeared to respond to gravitational tugs in ways that looked calculated, as though adjustments were being made. This raised deeper questions. If 3IATLAS is not a natural body, then what exactly is it? Could it be a derelict probe from a civilization millions of years older than ours, drifting through space until it found another planetary system? Or is it an active messenger, deliberately launched and guided to pass close to planets like Mars? The suggestion that we may be witnessing alien technology is not one that scientists make lightly. It challenges centuries of assumptions about humanity's place in the universe. But 3IATLAS refuses to fit neatly into the familiar categories of comet or asteroid. It is something different. And the fact that it has come so close to our solar neighborhood, heading toward the red planet, only deepens the mystery. As more evidence accumulates, Avi Loeb's voice has grown louder, urging the scientific community not to dismiss the possibility too quickly. He warns that labeling the object as just another comet could blind us to the reality that we may be looking at the first true sign of advanced life beyond Earth. And if he is correct, then 3IATLAS is not just passing through, it is a message, a machine, or perhaps even a test. When astronomers first locked onto 3IATLAS in early July, the general consensus was reassuring. This interstellar traveler, though fast and unusual, seemed destined to sweep past Mars at a safe distance. It would be spectacular to observe, but ultimately harmless. A cosmic firework flashing by, and then vanishing back into the darkness of deep space. But that sense of calm didn't last long. As more observatories began to feed in their data, both Harvard's team and NASA's Jet Propulsion Laboratory took a closer look at the object's path. What they found quickly erased the comfort of that early assessment. The trajectory wasn't stable. In fact, it was tightening. Instead of drifting along a predictable course, 3IATLAS was bending inward toward Mars in a way no one had expected. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. The updated calculations are nothing short of alarming. According to current models, 3IATLAS is now projected to make its closest approach to the red planet on September 26, 2025. The distance? Just 1.95 million kilometers. In the scale of interplanetary space, that's razor thin, close enough that Mars's gravity could actually begin to tug at the object, influencing its motion in subtle but critical ways. To put it into perspective, this distance is about 5 times the gap between Earth and the Moon. In everyday terms, that might sound wide, but in orbital mechanics, it's a cosmic near-miss. The difference between a safe flyby and a direct impact comes down to tiny deviations, sometimes no more than a fraction of a degree or a few seconds of acceleration. And with every hour that passes, gravitational nudges from the Sun, Jupiter, and Mars itself are reshaping 3IATLAS's course in ways that add up over millions of kilometers. Astronomers describe the situation as a balancing act on a razor's edge. Even now, as predictions improve, the object's path is being updated almost daily. The closer it gets, the harder it becomes to ignore the possibility that Mars could end up directly in the crosshairs. What makes this more unsettling is the speed at which these changes are happening. Normal comets can wander in their orbits due to outgassing, plumes of gas and dust that act like tiny thrusters. But 3IATLAS is accelerating and adjusting in ways that look deliberate, not random. Every shift in its path seems to tighten the noose around Mars, as if the red planet is the destination rather than an accidental bystander. If these calculations hold, Mars is not just going to get a close encounter. It could be staring down the most dangerous cosmic visitor in its recorded history, and the date is already circled on every astronomer's calendar. Late September 2025. That is when we will know, once and for all, whether 3IATLAS will simply graze past Mars or collide with devastating force. If the trajectory of 3IATLAS wasn't enough to raise alarms, its sheer speed has left scientists stunned. This object is not just moving fast, it's moving faster than anything humanity has ever recorded coming into the solar system from interstellar space. Current measurements place its velocity at an astonishing 87 kilometers per second relative to the Sun. To put that into perspective, imagine the vast gulf between Earth and the Moon, a distance of nearly 400,000 kilometers. At its present speed, 3IATLAS could cover that distance in less than 80 minutes. That is faster than the speed of most spacecraft by several orders of magnitude, faster even than the escape velocity needed to break free from our solar system. It is, quite literally, a bullet tearing across the cosmic void. But speed alone isn't the only concern. The more dangerous factor is what happens when an object moving this fast interacts with the gravitational forces of the solar system. Every planet, every moon, even the Sun itself exerts a pull. For a normal comet, these tugs shift the orbit slightly, nudging it onto a new but still predictable path. For something as fast and massive as 3IATLAS, however, even the smallest nudge becomes magnified over time. Astronomers have calculated that with each passing hour, the object's trajectory is being adjusted by mere micrometers per second. On paper, that might sound insignificant, almost laughably small, but stretched across tens of millions of kilometers. These minuscule changes add up to vast deviation, enough to alter whether the object harmlessly grazes past Mars or collides with devastating precision. This is why scientists describe the situation as unstable. 3IATLAS is like a high-speed train racing along a track where even the slightest bend could send it careening into disaster. Its momentum makes it incredibly resistant to stopping, but frighteningly sensitive to the tiniest directional changes. That combination of unstoppable speed and razor-edge instability is what has NASA and Harvard astronomers on edge. The real question is this: are these shifts in its path purely natural, the result of random gravitational pulls and chaotic outgassing? Or are they being guided, deliberately steered, to ensure a closer and closer pass toward Mars? If the latter is true, then this isn't just a speeding interstellar rock. It's something with intent, something capable of navigating with precision at velocities that dwarf anything humanity has ever engineered. The faster it moves, the harder it is to ignore what is at stake. A flyby would be historic enough, the fastest interstellar visitor ever observed. But a collision at these speeds would unleash energy on a scale almost beyond comprehension. And every hour that ticks by brings the object one step closer, its course more refined, its future more uncertain. For centuries, astronomers have studied comets and their behavior as they journey closer to the sun. When sunlight strikes a comet's icy surface, frozen gases sublimate, venting into space in random bursts. These eruptions create the glowing tails we see streaking across the sky. But the one constant in cometary science is chaos. The vents are unpredictable, irregular, and never precise. 3IATLAS, however, is breaking every rule. Instead of releasing gas at random intervals, telescopes around the world have detected an astonishing pattern: precise, clock-like pulses every 17 minutes. Not once, not twice, but over days of continuous observation, this rhythm has held steady, as if the object were running on some kind of internal timer. This is not the behavior of a natural body. No comet in the solar system has ever demonstrated anything like it. In fact, scientists liken it to the ticking of a metronome or the steady firing of thrusters on a spacecraft. Each pulse releases gas in a controlled burst, producing just enough force to subtly shift the object's path. And when those shifts are added together over time, they form a clear pattern. The object is being steered toward Mars' orbital plane. Think about the implications. Natural comets vent when sunlight heats fresh patches of ice, and those eruptions are chaotic. Jets firing here, then there, often breaking apart the nucleus as the comet tumbles through space. But 3IATLAS behaves with an eerie precision. The gas doesn't erupt randomly. It fires in deliberate, synchronized jets, as though following instructions. Astronomers watching this phenomenon have admitted that no known natural process can explain such clockwork regularity. One researcher described it as attitude control, the exact same technique spacecraft use to adjust their orientation and trajectory with small bursts of propellant. It's as if 3IATLAS is flying itself, adjusting its course step by step as it races through the solar system. And the target of these adjustments? Mars. Each synchronized outburst appears aligned to gradually reduce the missed distance, pulling the object ever closer to the red planet's path. By September of 2025, the cumulative effect of these tiny pulses could shrink the gap from millions of kilometers to just tens of thousands, closer than some of Mars's own moons. If this is merely coincidence, it is the most extraordinary one in the history of comet science. But if it isn't, then what we are watching is no random outgassing at all. It is navigation, deliberate, precise, and perhaps purposeful. The question then becomes chilling. Who or what programmed this interstellar traveler to behave this way? The tightening trajectory of 3IATLAS has led to one terrifying possibility: a direct collision with Mars. Right now, the object is still on course for a near miss. But astronomers warn that it wouldn't take much to tip the balance. A change of just 10 kilometers per second in velocity, a tiny fraction compared to its current speed, could redirect the object straight into the red planet. This isn't a far-fetched what if. The outgassing pulses already observed are providing small but steady bursts of thrust. And if one of those bursts happens to align just right, it could provide the additional momentum needed to shift its orbit into a collision path. In other words, the comet may already have the means to deliver that final push. If impact occurs, the consequences for Mars would be catastrophic. Scientists estimate the mass of 3IATLAS at nearly 10 billion tons, with a dense metallic core roughly 400 meters across. A body of that size striking at interstellar velocity would unleash an explosion equivalent to 2 million megatons of TNT. That's not twice the yield of the largest nuclear device ever tested. It's thousands of times greater. The crater left behind would be apocalyptic in scale, 60 kilometers wide and 5 kilometers deep, a wound carved into the Martian surface that would remain visible for eons. Shock waves would ripple across the planet, while molten debris would be thrown high into the atmosphere and far into space. Some of it could even escape Mars's gravity entirely, spreading across the solar system. And the damage wouldn't be confined to the planet itself. Mars is a hub of exploration, home to orbiters, rovers, and landers from multiple space agencies. Satellites like the Mars Reconnaissance Orbiter, the European Mars Express, and surface missions like Perseverance and Curiosity form the backbone of our Martian science. An impact of this magnitude could destroy or cripple decades of progress in a single instant. Communications relays could vanish. Climate data, life search missions, and future human exploration plans could all be set back by generations. For scientists, the potential impact represents both nightmare and opportunity. It would be the largest planetary collision witnessed in the modern era, a once-in-a-civilization chance to study interstellar material interacting violently with another world. But it would come at an enormous cost, the loss of billions of dollars in equipment, and possibly the contamination of Mars itself with materials that may not be natural at all. The thought that this could happen, not in millions of years, but in just over 12 months, is what keeps researchers awake at night. September 26, 2025, looms ever closer, and with it, the possibility of a collision that could rewrite the history of Mars, and perhaps the history of intelligent life in the cosmos. Up to this point, the anomalies of 3IATLAS could be explained away, at least in theory, as rare but natural behaviors. An odd trajectory, strange gas emissions, even its incredible speed might be stretched into the realm of possibility. But the most recent evidence is something altogether different. Deep space radar facilities, including NASA's powerful Goldstone Solar System radar in California, have been quietly tracking 3IATLAS since its discovery. Normally, when comets are scanned this way, the echoes return soft and diffuse, consistent with surfaces of ice and dust. But the radar profile of 3IATLAS was nothing like that. Instead of scattering gently, the radar beams bounced back with hard metallic echoes, the kind of reflection you'd expect from steel, titanium, or other dense alloys. Materials like these are not formed naturally in the void of interstellar space. They are forged, engineered. For weeks, these results were kept classified, locked away in restricted data servers. But leaks began circulating among the scientific community, hinting at something extraordinary. Harvard astrophysicist Avi Loeb, already controversial for suggesting Oumuamua might have been artificial, went public with his interpretation. Working with one of his graduate students, he argued that the echoes prove 3IATLAS is not just another comet, but a structure, possibly a technological artifact, cloaked beneath a thin shell of ice to masquerade as a natural object. This theory may sound like science fiction, but consider the evidence: the precise, timed outgassing pulses behaving like thrusters, the deliberate alignment with Mars's orbital plane, and now, radar signatures indicating alloys unknown in natural comets. Loeb describes the object as resembling an interstellar probe, a machine built by some intelligence, its metallic frame hidden beneath volatile ices that create a convincing comet-like disguise. The ice would not only provide camouflage, but also serve as fuel, vented in exact amounts to alter its trajectory, just as we've observed. If true, 3IATLAS could be the first piece of alien technology humanity has ever encountered up close. Not a distant radio signal, not a mathematical anomaly. A physical machine, a visitor crossing the gulf between stars. But if this is technology, the biggest question isn't how it works. The question is why it's here, and why, of all the planets in the solar system, It seems to be steering itself toward Mars. While scientists debate whether 3IATLAS is natural or engineered, a series of unsettling observations from Mars has pushed the discussion into darker territory. The European Space Agency's Mars Express orbiter has been circling the red planet since 2003, providing some of the most detailed imagery of its surface and atmosphere. But in the last several months, its instruments have recorded something unusual: 3 small, highly reflective objects glinting just above the Martian atmosphere. At first, mission engineers brushed it off. Cosmic rays often streak across detectors, leaving behind bright specks that mimic objects in space. But this wasn't a one-time glitch. The same 3 reflections appeared again, and again, and again. Each time, they were in the same positions, locked in what astronomers now describe as a triangular formation. Cosmic rays don't form triangle, and they don't maintain formation across multiple imaging passes. The unsettling implication is that these aren't sensor artifacts at all. They could be physical craft, small probes or satellites, deployed silently into orbit around Mars. Their reflectivity suggests metallic surfaces, and their spacing is consistent with a controlled configuration rather than random debris. If this interpretation holds, it leads to an extraordinary hypothesis. 3IATLAS may not be arriving alone. It could already have dispatched scouts ahead of its approach, like reconnaissance drones preparing the ground for something larger to come. The timing is difficult to ignore. These reflective anomalies first appeared in the months after 3IATLAS was detected entering the solar system, as if its presence was the trigger. Skeptics argue there must be a mundane explanation: fragments of Martian moons, perhaps, or untracked space junk from past missions. Yet neither Phobos nor Deimos can account for their exact altitude or their stable geometry. And human spacecraft? None are known to be operating in that orbit, let alone in precise triangular formation. If these really are probes, their mission is a mystery. Are they monitoring Mars's surface? Mapping its resources? Tracking our satellites and rovers? Or are they simply waiting, relaying data back to the larger object on its inbound course? For the first time, scientists are being forced to consider that 3IATLAS may not just be a visitor. It may be conducting operations, coordinated, strategic, and deliberate. And if that's true, then its destination isn't random at all. Mars may have been chosen long before we ever spotted it. The moment the anomalies of 3IATLAS became undeniable, the world's space agencies quietly shifted gears. Publicly, their updates remain calm, routine, and even dismissive, the kind of language designed to reassure rather than alarm. But behind the scenes, a very different story is unfolding. According to leaks from inside the aerospace community, the major space powers, NASA, ESA, Roscosmos, CNSA, and JAXA, have all formed emergency planetary defense task forces. These aren't ordinary working groups. They're cross-agency teams designed to share classified data, track unusual threats, and coordinate potential responses. In short, humanity's first line of defense against the unknown. While the press releases speak blandly of monitoring efforts, internal documents suggest something far more serious. A memo leaked from NASA's Jet Propulsion Laboratory describes efforts to repurpose existing spacecraft around Mars. Probes like the Mars Reconnaissance Orbiter, once dedicated to mapping the Martian surface, are now being retasked to focus almost exclusively on 3IATLAS. Every maneuver, every anomalous burst of gas, every flicker of reflected light is being logged with military-level precision. ESA's Mars Express, 2, has been placed on a new observation schedule, tasked with keeping its cameras fixed on the strange reflective objects in Martian orbit, the ones some now believe to be scout probes. Meanwhile, China's CNSA has quietly announced unplanned adjustments to its Tianwen-1 orbiter, a cryptic phrase that analysts suspect also means redirection toward tracking 3IATLAS. The secrecy is telling. None of these agencies are openly admitting to the scale of their concern, but the coordination itself is unprecedented. These nations are rivals, often reluctant to share even basic mission data. And yet, In the case of 3IATLAS, information is flowing rapidly between them, as though they all recognize the stakes are too high for competition. There are even whispers that military satellites in Earth orbit have been reassigned to deep space surveillance, feeding classified intelligence directly to these planetary defense teams. If true, this means the response is no longer purely scientific. It is strategic, defensive, acknowledging that this object might not be just a natural hazard, but a potential technological adversary. For now, the public sees only calm statements and routine reports. But behind closed doors, humanity is mobilizing. Because if 3IATLAS is truly artificial, then its approach to Mars may represent not just a scientific puzzle, but the first interstellar test of whether our civilization is ready to face another. Even if 3IATLAS were to narrowly miss Mars, the consequences of its close encounter could still ripple across the solar system. A collision, or even a near miss at high speed, would send shockwaves through space in ways that go far beyond the red planet itself. Scientists warn that an impact could eject millions of tons of debris into interplanetary space. Some of this material would remain trapped in orbit around Mars, forming temporary rings of dust and rock. Other fragments could escape the planet's gravity entirely, hurtling through the solar system at incredible speed. These aren't ordinary rocks. Given the possibility that 3IATLAS may contain metallic or engineered components, some of the debris could carry traces of material that are artificial or highly unusual. Computer models predict that certain fragments could reach the vicinity of Earth within a decade. While most would burn up in our atmosphere, larger or more robust pieces might survive entry, landing on our planet or in near-Earth orbit. The implications are unsettling. If any fragments carry engineered microbes, chemical compounds, or even self-replicating nanotechnology, they could introduce previously unknown elements into Earth's environment. This scenario moves beyond the realm of planetary science and into biosecurity and astrobiology. Governments and space agencies are acutely aware of the stakes. What arrives from Mars in 10 years could, in theory, carry interstellar materials that are entirely new to life on Earth, or worse, potentially hazardous. Even if a collision doesn't directly threaten Earth, the debris field could create hazards for spacecraft, satellites, and future missions throughout the inner solar system. Every probe, rover, and satellite operating in the path of Mars's orbital debris would need recalibration and rerouting to avoid catastrophic impacts. What's clear is that the risk is not isolated to a single planet. A single interstellar object, moving at extreme speed and potentially under intelligent control, could reshape the solar system's environment for decades. Mars may be the immediate target, but the ripple effects, fragments, debris, and possibly engineered materials could extend all the way to Earth and beyond. For astronomers, this is both a warning and a call to vigilance. The universe is vast, but objects like 3IATLAS prove that a single, small point of light racing through the void can have consequences on a planetary scale. As the data on 3IATLAS continues to mount, a sobering possibility emerges. What if this interstellar object is not just a random visitor? What if it is maneuvering deliberately, adjusting its course with precision, and approaching Mars for a reason? If that is the case, then humanity may be on the brink of witnessing something truly unprecedented, the first confirmed extraterrestrial technology in human history. For decades, we have imagined the ways we might detect intelligent life beyond Earth. Most discussions focus on radio signals, faint whispers sent across the cosmic void, waiting for a civilization like ours to listen. We have scanned the skies, hoping for a message hidden in the static. But 3IATLAS challenges that paradigm entirely. It suggests that first contact might not come through communication at all. It might come as action, as a physical object crossing light years, carrying a message, a probe, or even a test of our observational skills. This shifts the conversation from passive listening to active awareness. If 3IATLAS is indeed an intelligent artifact, then every gas pulse, every slight adjustment in its trajectory, is a signal in itself. It may be observing Mars, studying our solar system, or gauging how we respond to its presence. The object's approach is not random. It may be designed to interact with us indirectly, testing our ability to detect, interpret, and react to extraterrestrial engineering. The implications are staggering. A guided interstellar impactor could represent a civilization millions of years ahead of ours, capable of constructing and controlling objects across interstellar distances. It would suggest that intelligent life has not only survived, but mastered technology far beyond anything we can currently comprehend. And the potential consequences extend beyond mere curiosity. A collision with Mars could alter the planet physically, possibly releasing debris into the solar system, fragments that might even reach Earth over the coming decades. If any of these fragments carry engineered material or other technologies, the impact would have ramifications that reach far beyond the immediate scientific community, touching on planetary defense, biosecurity, and the very question of humanity's place in the universe. For astronomers, physicists, and planetary scientists, this is the opportunity of a lifetime, a chance to study an interstellar object in real time, possibly confirming the existence of intelligence beyond our planet. For everyone else, it is a cosmic warning. The universe may be far stranger and more active than we have ever imagined. As September 2025 approaches, all eyes will turn to Mars and the sky above it. The silent pulses of 3IATLAS may soon answer the age-old question, are we alone? But the answer may come not as a gentle signal, but as a glowing green comet, racing at unimaginable speed, threading the eye of a cosmic needle, and possibly rewriting humanity's understanding of its place in the cosmos. The universe is watching, and so, it seems, is something else. As we watch Mars rise in the night sky this September, remember that above the rusty horizon, something extraordinary is unfolding. 3IATLAS is threading the eye of a cosmic needle, pulsing its strange green exhaust, adjusting its path meter by meter. We do not yet know if it is a natural object, a guided interstellar visitor, or a piece of technology from a civilization far beyond our own. But one thing is clear, the universe has a story to tell, and this time, it may be coming directly to our celestial neighbor. Whether 3IATLAS passes safely, grazes Mars, or collides with devastating force, humanity is witnessing an event unlike any in recorded history. A cosmic experiment, a warning, or perhaps a first contact that challenges everything we think we know. The question remains, are we alone, or is someone, or something, out there, watching, testing, and reaching across the stars? Keep your eyes on the skies. History is unfolding, and soon we may see the answer in motion. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.